Hello and good day. Welcome to the School of RHK. This tutorial is designed for O-level students. The subject we will discuss is physics. This tutorial is a part of physics course. Section 1 is general physics. In module 1, we will cover measurements and motion. This tutorial is to learn about measurements. There will be several parts of this tutorial. This is the first part. Now, under the topic measurements, we will cover initially about units and basic quantities, where we will try to understand what is unit, what are the basic quantities, what is SI, what is decimal system, and the power of 10 shorthand. Let's start with unit. So what is unit? Before we discuss what is unit, look at the picture on the left hand side. This picture shows a meter rule trying to measure the height or length of a miniature model of a house. All of us are familiar with the function of meter rule. If we measure the length or height, we say it is 4 or 5, or let's say x meters. But have you ever thought what does the word meter stands for? This is what we call a unit. Here the unit for measuring length or height is meter. So to measure the size of the quantity can be found within an instrument. Here the instrument is meter rule and having a scale marked in the unit. In this case, meter is the unit. By definition, a unit in any standard used for making comparison in measurements. That is, to measure any physical quantity, we use units. We will discuss here about the basic quantities. Considering the context, the basic quantities can change. For an example, if we see the picture, it shows the measuring instruments on the flight deck of a passenger jet. All the measuring instruments provide the crew with information about the performance of the aircraft. In context of a passenger jet, during the flight, the airspeed or the altitude or the oil temperature or all of them may fall under the basic quantities. However, in context of physics, the basic quantities are different. In context of physics, length, mass, and time are three basic quantities. Units for other quantities in physics are derived based on these three basic quantities. The unit for length is meter, the unit for mass is kilogram, in short we say kg, and the unit for time is second. The International System of Units, SI, abbreviated from the French Système International des Unités, is the modern form of the metric system. It is the only system of measurement with an official status in nearly every country in the world. It comprises a coherent system of units of measurement, starting with 7 base units. The 7 base units are: the second, the unit of time with the symbol S; the meter, the unit of length with the symbol M; the kilogram, the unit of mass with the symbol kg. The ampere, the unit of electric current with the symbol of capital letter A. The Kelvin, the unit of thermodynamic temperature with the symbol of capital letter K. The mole, the unit of amount of substance with the symbol MOL. And the candela, the unit of luminous intensity with the symbol CD. This system allows for an unlimited number of additional units, called derived units. It is a decimal system in which units are divided or multiplied by 10 to give smaller or larger units respectively. We will discuss the details in what is decimal system. First, we will try to understand what is decimal system as a part of number system, and secondly, the powers of 10 shorthand. In the numeric system, each number is represented by its base. There are 4 number systems known as a binary number system if the base is 2. One of the use is computer communication. An octal number system if the base is 8. One of the use to mention computer memory capacity. A decimal number system if the base is 10 is vastly practiced in daily life for its simplicity. The hexadecimal number system if the base is 16, one of the use to mention the memory address of the computer. A detailed discussion on number system or decimal system is beyond the scope of this tutorial. Coming to the second part, why we need to know the powers of 10 shorthand. Due to its neat way of writing numeric value, in physics, powers of 10 shorthand is used. Especially in physics, we need to deal with large and small numeric values. For instance, the distance between Earth and Sun is 149,600,000 kilometers, or the mass of an carbon-12 atom in gram is 0.230, then 166053904. Any numeric value has a base and a power. If the numeric value is n, the base will be n itself and the power will be on the top, as written here in superscript. Coming to the powers of 10 shorthand, the base will be always 10. In terms of base and power, we should write 10 to the first power. But conventionally, if a digit has the power to the first, we write the base without the power. If 10 has a power to the minus first, then the numeric value will be 1 over 10 to the power of first. If any base number has a power of 0, the numeric value will be always 1. So, if we write 10 to the power of 0, it will have the numeric value of 1. Some examples are as follows. The first column represents the numeric value in regular expression. The second column for the clarity, and then the third column is the standard notation in terms of powers of 10 shorthand. What is standard notation? Any numeric value, when expressed in the powers of 10 shorthand, is also known as scientific notation or standard notation of a numeric value. Here the first regular expression is 5000. The standard notation in the powers of 10 shorthand of 5000 is 5 multiplied by 10 to the power of third. For 500, the standard notation is 5 multiplied by 10 to the power of second. For 50, the standard notation is 5 multiplied by 10 to the power of first. For 5, the standard notation is 5 multiplied by 10 to the power of 0. For 0.5, the standard notation is 5 multiplied by 10 to the power of minus first. For 0.05, the standard notation is 5 multiplied by 10 to the power of minus second. And the last one, for 0.005, the standard notation is 5 multiplied by 10 to the power of minus third. In simple words, we can say the small figures written in superscripts are called power of 10. The power indicates how many times the number has to be multiplied by 10 if the power is greater than 0, or how many times the number has to be divided if the power is less than 0. And if 10 has a power of 0, it is equal to 1. Let us see an example of a large numeric value. The distance between the Earth and Sun is 149,597,870 kilometers, or to be 149,600,000 kilometers roughly. If we write the distance of the Sun from the Earth, it would be a big number. Think, for any good reason, if we need to write the distance between Earth and Sun in the examination repeatedly, how laborious as well as hectic it will be for such repetition. To write it in a neat way, we will use the scientific or standard notation. In this notation, we write the number in the form of the powers of 10 shorthand. So the distance between Earth and Sun in standard notation and oblique or scientific notation is read as 149.6 multiplied by 10 raised to the power of 6 kilometers. To be read in regular form, 149.6 million kilometers. Let us see an example of a very small numeric value now. The mass of a carbon-12 atom in gram is 0.230, then 166053904. In writing, repetition of such number has a high chance of error, as so many zeros need to be added after the decimal point and before the original numeric value starts. To avoid that, we can use the power of 10 shorthand. So, if we want to write the mass of a carbon-12 atom with scientific and oblique or standard notation, it would be read as 1.66053904 multiplied by 10 raised to the power of minus 24. We will conclude here today as the first part of this tutorial, and we will cover other remaining topics of measurements in the second part of this tutorial. If you dislike our tutorial, please write in the comment section or send us email in rhkstorecouk@gmail.com with your query. However, if you like the tutorial, please subscribe, give us a thumbs up, do share, and please do not forget to press the bell icon. Thank you for your time and patience to watch the tutorial, and hope you have enjoyed the tutorial. Stay home and stay safe.